Okay, this is lesson number 3, still looking at sketching parabolas, but using the completed square form. Okay, so what we've done so far was sketching parabolas based on just plotting a series of points. We then looked at plotting parabolas based on their routes, and there's a third method of doing this that is using the completed square form. Okay, so remember, your completed square form was anything that looked like this. Okay, so we looked at that back in unit 2, I believe. Converting quadratics into the completed square form. We can use that to sketch parabolas. Okay, so as our first example, I'll just work you through this. So example 1, sketch y equals x minus 2 squared plus 1, showing the turning point and y-intercept. Okay, so again, similar to what we looked at with the roots, we're given a wee checklist of information we need to have in our answer. Okay, so sketch the graph of y equals x minus 2 squared plus 1. What we're going to do is start off just with this turning point, okay, and that always comes at the point of negative whatever this number is here. Okay, so the first number, the one in the bracket, gets flipped. So in this case, because it's a negative 2, our turning point is at positive 2. Okay, and then the number outside your bracket just stays the same. Okay, so that negative 2 becomes a positive 2, and this 1 just stays a 1. Okay, x and y, easy as that. Okay, and that comes from those 2 bits of information there. Nice and simple. Okay, what we now have to consider for our y-intercept is that at the y-intercept, x is going to be 0. Okay, because this is the point where it cuts through the y-axis. Right on that y-axis is going to be 0 for x because we haven't moved left or right at all. Okay, all we have to do now is say, well, y equals 0 minus 2 squared plus 1. We're just taking that 0 and substituting into our original equation. 0 take away 2 is negative 2, square that is 4, plus 1 is 5. Okay, what we can now do is knock up just a quick sketch of this. Okay, so we've got x, y, and our origin. Turning point is at 2, 1, so let's say that's about here. Okay, and then the y-intercept of 5, let's say that's roughly there. Okay, it is just a sketch, it only needs to be approximate. This is our turning point, and so our graph is going to come down, turn through there, and come back up. And it is always just worth noting your turning point's coordinate next to it as well. It is just a sketch, it doesn't need to be accurate, but because you're asked for these 2 points, you need to make sure that you have marked them clearly on your diagram. And you can see there, we've got a parabola like we got from plotting all the points out, but we've had to do significantly less work in order to get it. Okay, we're going to take a look just at a wee second example. Okay, I'm just going to move this up a wee bit. Okay, so we're going to have a quick look at a second one just to show you how it can differ. Okay, so this time, same question, but we're now looking at y equals negative x plus 1 squared plus 1. Okay, so 2 things have changed here. I'll just finish this off showing turning point and y-intercept. Okay, 2 things have changed here. So where we had a negative in our first example, we've now got a positive inside our bracket here, and where it was just y equals bracket x minus 2, this time we've got a negative in front of the bracket. Okay, so our turning point is going to be at, and it's still the exact same, okay? This time, -1 and 1. So that one stays the same. And again, this one, the sign changes, okay? So because this is positive, this becomes negative. Okay, because this is positive, this becomes negative. In terms of where the turning point is, this negative outside the bracket has no impact on the turning point at all, okay? So that process stays the exact same. This does not matter, okay? Our y-intercept, again, we're going to say that x equals 0, so y is going to be negative 0 plus 1 squared plus 1. So that is going to be negative of 1 squared plus 1. Just note, this is not -1 squared. This is 1 squared and then turned into a negative, okay? So it's going to be -1 plus 1. So it's actually at 0 as 0. Okay, and again, all we're going to do here is just sketch a wee set of axes. There's my x, there's my y, there's my origin, and my turning point is at -1, 1, so let's call that about there. Okay, and then because my y-intercept is right through 0, 0, the origin, what you can see here is that the y-intercept is below the turning point. So what that means is that our parabola is going to be one that looks like this. So that negative outside the bracket changes it to be this upside down U shape. Okay, if you prefer, a little memory aid that quite a lot of people use is that here the expression is positive, and so we have a happy face. Here it's negative, so we have a sad face. Okay, just a wee memory aid. If it helps, great. If not, feel free to disregard it. Okay, but that's the basics. As long as you're careful and as long as you remember that the turning point is not impacted at all by a positive or negative outside the bracket, you remember to flip the first number and keep the second one the same. You should be absolutely fine.